In Young's double slit experiment, deduce the condition for constructive and destructive interference at a point on the screen. Draw a graph showing variation of intensity in the interference pattern against position X on the screen. Compare interference pattern observed in Young's double slit experiment with single slit diffraction pattern and tell about three distinguished features. Plot a graph to show variation of angle of deviation as a function of angle of incidence for light passing through a prism. Derive an expression for refractive index of the prism in terms of angle of deviation, minimum deviation and angle of prism. What is dispersion of light? What is its cause? A ray of light incident normally on one face of a right isosceles prism is totally reflected. Find minimum value of refractive index of glass. Experiment. From this figure we can find out part difference equals to S2P minus S1P. Squaring and putting these values, we get S2P plus S1P into S2P minus S1P equals to 2XT. Now for X and D less than D, S2P plus S1P equals to 2D. Subtracting these two equations, we get XD by D. For constructive interference, the difference equals to N pi. So putting N pi, we get X equals to N lambda D by D. For destructive interference, it equals 2N plus 1 into lambda by 2. So substituting this value, we get X equals to 2N plus 1 into lambda D by 2D. This is a graph showing variation of intensity pattern against position X on the screen. Now, talking about interference pattern, it has number of equally spaced bright and dark bands, while in diffraction pattern, width of central maximum is twice width of other maxima. In interference, all bright fringes are of equal intensity, whereas in diffraction pattern, intensity falls as order of maxima increases. In interference pattern, maxima occurs at an angle lambda by A, where A is slit width, but in diffraction at same angle, first minimum occurs, hence A is size of the slit. Now let us draw a graph to show variation of angle of deviation as a function of angle of incidence. Now this is the angle of incidence I1, I2, angle of deviation del and del m. So the variation can be shown as follows. From this diagram we can find the value of r as a by 2. Del, we know that del equals to I plus e minus a, so dm becomes 2i minus a, and from this I becomes a plus d by 2. We know that mu is equals to sin a by sin r, so substituting value of I and r, we get mu equals to sin a plus d by 2 upon sin a by 2. Now, phenomenon of splitting of white light into its constituent colors is called dispersion of light, and its cause is that refractive index of material is different for different colors. According to the equation, it is not equal to mu minus 1 into a, where a is angle of prism. Now, a ray of light incident normally on one face of a right isosceles prism is totally reflected as shown in given figure. So, total internal reflection, angle of I is greater than critical angle. So 45 degree is greater than critical angle, which means that sine of critical angle is less than 45 degrees. So putting the value of sine 45 as 1 by root 2, we get mu is greater than equal to root 2. Hence minimum value of refractive index must be root 2.